The marginal cost and average cost curves are actually derived from your long run total cost curves. So if you are not clear on the topic of long run total cost and short run total cost, I suggest that you go back to the previous video, you can revise yourself. Okay, this is the copy of the mind map. Okay, we will start with marginal cost first. So what is marginal cost? Marginal cost is the additional cost incurred for every additional unit produced. Okay, so in an example like this, okay, 1 unit produced costs $10, 2 units produced cost $20. The increment in price is 10, so therefore the marginal cost is 10. For 3 units produced, the total cost is 35. 35 minus 20 gives you 15. So on and so forth. To find marginal cost, you take the change in total cost divided by the change in X. So this should remind you of this graph over here, and every time there is a change in the y-axis figure divided by the change in x-axis figure, it is a reminder of the gradient. So that means the gradient of the total cost curve will give us our marginal cost curve. To do this, okay, you will draw tangents on the total cost curve. Okay, in the case of our example, we'll be using the short run total cost. So the steeper the slope, the higher the marginal cost, and the flatter the slope, the lower the marginal cost. As you can see, we start high, and we go flat, and then we go high again. Therefore, the slope looks like this. This is the marginal cost curve. Moving on to average cost, it is more straightforward. It is the total cost divided by the total units produced. Such is the calculation for the average cost. To identify the average cost, we draw a slope. We draw a ray from the origin to the total cost curve, and we identify the gradient. The steeper this ray, the higher the average cost. So as you can see, we have drawn rays from the origin to the total cost curves. Okay, and we start from steep to flat, to flatter, and to steeper again. That is why the slope is shaped like this. Combining the two slopes together, the two curves together, there are 3 steps. Step number 1, you will identify the minimum average cost. To identify the minimum average cost, you draw a slope, okay, a ray from the origin to the total cost curve, where is the flattest. So it becomes a tangent to the total cost curve. Okay, you bring that down to the bottom graph, and that is your minimum point. You draw the short run total average cost like this. Then that's step 2. Step 3, you draw in the marginal cost like this. Why is the marginal cost lower at this point and higher at this point than the average cost? Because if you compare this point over here, this is the ray and this is the tangent. The ray is steeper than the gradient of the tangent, therefore the marginal cost is lower. Ray steeper, average cost higher. Tangent flatter, marginal cost lower. And at this point, the marginal cost will meet the average cost because this ray is also a tangent, which means that your average cost equals to your marginal cost. We will now add in the short run total cost and the long run total cost together, which will give you a slope like this. And this is the step-by-step instructions on how to draw these following graphs. Okay, we will now use an example to do so. Okay, let me show you how this can be done. Okay, So we have over here, okay, the total cost curves. And here we have marginal cost, average cost, and marginal cost. Okay, so let's draw the total cost curves in first. Okay, this is my short run total cost. Okay, I'll be using short forms from now on, SRTC, and this is my LRTC. Okay, so this is the point of intersection. At this point, the SRTC meets the LRTC. And you should also know that this point is where the short run expansion path meets the long run expansion path, as mentioned in the previous videos. Okay, so what is step 1? Step 1, identify minimum long run average cost. Step 2, draw long run average cost. LRAC. Step 3, identify minimum SRAC. Let's do that first. Second part of step 3, intersection point with LRAC. How do we find that out? It is always this dotted point over here. Why is that so? Because if I draw a ray from the origin to this point, okay, the ray that meets the LRTC is also the ray that meets the SRTC. So when they share the same ray, that means the average cost is the same. Therefore, at this point, that is where the LRAC will meet the SRAC. Minimum point over here, 1 point, 1 point, so this is what the SRAC will look like. SRAC. Next step, okay, we have drawn the SRAC. Step 5, draw LRMC. You know that the LRMC will meet the LRAC at its minimum point over here, and you just got to make sure that it would go all the way past this point, and you will find out why later. LRMC. Okay, we are almost done. Now we will identify, okay, where LRMC equals to SRMC, and again it would be this point over here. Why? Because if I draw a tangent on this black point over here, the SRTC and the LRTC shares the same tangent line, which means that the marginal cost is the same, and that is where your LRMC will meet the SRMC. So we now have one point of intersection over here. Where is the other one? It will be at the SRAC. There. With much practice, it will be easy, okay, for us to draw this graph with little effort. Okay, so you will encounter and you will have to learn how to draw something that looks like this. Yes, this looks a bit like Spider-Man's web. Some people are even reminded of their grandmother's face because there are so many lines, but no problem. Okay, this and this, okay, will be scanned so that you will be able to draw these curves, you know, while you're practicing, and after doing it a few times you will be able to produce this. Okay, the important part about this, okay, is where the intersection of the LRAC and the SRAC is. Okay, so let's go through that. Now, this is my LRAC, and that's the minimum point. Okay, there are three possibilities. Possibility number one, my SRAC can touch this point here, and the minimum point will be on the right side of that, and it will go up. Possibility number one. Okay. Possibility number two, I can have it this side, where the minimum point is on the on the left side of the intersection. Okay, here. So this is SRAC2. Okay, what it means, okay, is simply this. When I draw in my LRMC, okay, you will notice that on the left side, okay, if my SRAC is something like this, okay, I will have my intersection points both at the same in the same line. We already know that from the previous slide. Okay, so adding in my SRMC1, it will look like this. Okay, so at this side over here, it shows that the firm is currently going through increasing returns to scale. I say again, increasing returns to scale. So when this point and this point, okay, take note of this, when the LRAC equals to SRAC is more than the LRMC equals to the SRMC, this is increasing returns to scale. Okay, at this point over here, I'm just going to draw in my SRMC2 for you to see. Okay, we know that, okay, it will intersect at the same line here. So like this, SRMC2. Okay, you can see that LRMC equals to SRMC is more than my LRAC equals to SRAC. Okay, at this point, the firm is going through decreasing returns to scale. Okay, there is one last possibility, okay, which is in the middle over here. So the short-run average cost looks like this. The minimum point of my SRAC3 meets the minimum point of the LRAC. So what's going to happen is that my marginal cost is going to look like this. So everything intersects here. At this point, where my LRAC equals to my SRAC, it is also equal to my LRMC equals to my SRMC. And that is where we have constant returns to scale.